networks are configured, and the example we'll use is adding a tablet to an existing home network to understand how it gets an IP address and how it's able to access the broader internet. In our example, I show that we have a PC and a router in a home network connected by an Ethernet switch. I'm going to add a tablet with the MAC address of 8853 to that network, and we'll understand how it contains the IP address. The first thing that happens when the tablet is attached, either via Wi-Fi, Ethernet, or Ethernet, is a DHCP discover message is sent over the Ethernet interface using a broadcast address. So I've shown the address here is a series of FF bytes, and that is the convention for Ethernet broadcast. When that message is sent on the local area network, all the DHCP routers that are on that network can respond with a DHCP offer request. In most networks, that's going to be the gateway router, those local area networks in the home, and there will be a single offer sent from that router. The response is addressed to the MAC address of the tablet. The MAC address is discovered with that DHCP discovery message, which lists the source MAC address. An IP address is offered to the tablet with the DHCP offer request, and the tablet can acknowledge that with a DHCP request. Now, the reason it's done that way is because there could be multiple offers, and so the tablet resolves which offer it wants to respond to with a DHCP request. When the DHCP offer message is sent, that IP address is taken from a pool at the DHCP server and is reserved for the life of the offer. If there's no response or no DHCP request received, then that address is no longer reserved and is available for assignment. The router responds by sending a DHCP acknowledgement back to the tablet, so now the tablet has a IP address. The address is leased to the tablet. It's not a permanent assignment, and rather it is on loan for a certain time to live. When that time to live starts to expire, the tablet can send another request to renew the lease on that IP address. The reason this is done is because tablets or hosts, PCs or any kind of host that gets a dynamic address may be disconnected from the network, and so that address would be stranded if there weren't a lease and renewal mechanism. The other advantage is during the DHCP exchange, a subnet mask is passed to the tablet, and so now the host receiving the address also knows which addresses can be reached on the local area network via Ethernet and can update the ARP table so that those devices can be addressed directly, and which ones need to go through the default gateway. A host name can also be exchanged as part of this, which means when you add a device to your home network, typically you'll have a way of assigning a name to that device, and that will be populated in the tables in the router so that the host name can be used rather than the IP address. So it saves a lot in system administration. And of course, the DHCP server is discovered, as well as the default IP gateway. So now our tablet has not only an IP address, but it also has all this other information. And importantly, the primary and secondary domain name system servers are discovered as part of this process. So with this simple exchange, we've completely configured our tablet for use in our network. So we have our IP address, and we also have access to the broader network, and I'll talk more about that in the next slide. But the DHCP exchange occurs not only in the local area network, it also occurs in the wide area network. In the same way that our tablet, got a IP address and all this associated information from the router. The router can make a DHCP discover broadcast within the ISP network and get an IP address in the wide area network, as well as learn about the DHCP servers and DNSs in the wider area network. ISPs don't necessarily configure the routers this way, but certainly they can, and it's a viable option for getting those wide area network assignments. So now we have our local area network configured, and we have private IP addresses for our tablet and our PCs, but we want to reach out to the internet in a public routing space in the wide area network, and of course we can't use our private addresses for that. So how are we able to make requests into the internet with the private addresses? Here's an example where in my tablet I want to make a query to Google, which is 74.125.227.132, using port 80, which is the well-known HTTP port for the World Wide Web. But I've got a source address, source IP address of .77 and a source port. So my TCP source port is going to be 47.535. One mechanism that allows this is called network address translation. And in the router, there will be a pool of public IP addresses. And when my host makes a request to Google, the router will be the default gateway. It'll see my request, and it will bind a public address, in this case 71.96.222.40, to my private address, and it will send a query to Google with that public address. Notice that the source port doesn't change with network address translation. So Google will see a publicly routable IP source address and port in the request, and will send the response back to the gateway. And because that public address is bound to my private address, it will simply substitute the private address in the response and continue to route the message back to my tablet. If a second request is made from the local area network to the same destination as shown here, then a second binding will take place in the router with a different public IP address. So the router has a pool of assigned public addresses that it can bind to TCP connections in this case. Now notice again that even though I've listed the source ports here, they do not change with network address translation. So let's look at a different process, and that is port address translation. If I were to make the same set of queries with port address translation, we'd see a different process. Again, in our example, I make the request from my tablet, which is .77. Again, it's bound at the router to a public IP address .40, but a different source port is used in the wide area network or publicly routable request. Now my source port inside the local area network is 47.535, but in the wide area network, the port that's going to be used is 56.455, and that's the port that Google would see. In our second request coming from the other PC, we see it has a source port of 57.880. It's going to be bound to a public port of 43.560. So Google will now see two requests with the same public IP address, 71.96.222.40, but with different source ports. And so they'll send responses. Both responses will go to the same IP address but with different source ports. There are advantages to each technique, network address translation and port address translation. A network address translation is simpler and less intrusive because only the IP address is exchanged, which is at the IP layer of the protocol. So the TCP layer is not affected, and that makes the translation a little easier. Simply stated, when a request comes from inside the local area network, the router only needs to look at the IP layer and substitute particular bound public address and then send the message on to its destination. With port address translation, the router has to look not only at the IP layer, it must look above that at the TCP or UDP layer, because the port address is not in the IP layer, it is in the TCP or UDP layer. So this means that the router is going to be a little more sophisticated. The great advantage of port address translation is it only uses one external IP address. And we're going to see later that IPv4 addresses are an exhaust in part of the world and nearing an exhaust in the United States, so the conservation of IP addresses is very important. Both NAT and PAT have limitations. There are some applications that do not work well across either NAT or PAT, but particularly PAT can be problematic. And the reason is some applications like voice over IP may use the IP address in the application layer of the protocol. And most routers that support NAT and PAT are just doing a simple translation, and they are not sophisticated enough to look inside the application layer. For that, there's a technology called an application level gateway, an ALG, which is more sophisticated and a technology that's not likely to be in many homes because of the degree of complexity and support that's required. So these are great techniques for simple web addressing and web requests, but they do have their limitations. There are two other implications of using NAT and PATting for wide area network access and services, and that is that the translation point, the router, provides an opaque barrier to the local area network. And what that means is websites like Google or other sites within the internet really can't see the hosts that are behind the gateway. So it provides a level of security, although it is not a security mechanism, but it means that entities outside the local area network are going to have a hard time being certain of the host that they're looking at just using the IP address. There are other mechanisms that these sites use to determine which host they're talking to, but it does provide some degree of opaqueness and hides the host identity to some extent. The other issue is that there's no good way for a website to push a request into a local area network. That is, that all of the communication from inside a private address space to the internet must be initiated by the host, simply because the site can't be sure of the address, and there's no reverse binding that automatically takes place unless the gateway is set up with static addresses so that a address is statically bound rather than dynamically bound to the host. So if you want to put a website in your home, you must configure the gateway router to bind that private address and port with a public address and port, so that every time a query comes to the router, then it will be forwarded onto that private address. So that is a capability that some people use, but it complicates the configuration of the home network because you have to go through